Okay, back to this. If I'm looking at r equal 2 minus the sine of theta, well, we know sine is the y, and since it's negative, the graph look something like this. Okay, you know what? That's a bit too big. There. We know the graph will look something like this, a heart-shaped arc around the negative y-axis, or it could have a loop. How are we going to figure that out? We're going to sketch the graph of one period, just one will do. Don't need to do much. Here we go. And if I go to r equal 2, let's say that's 1, 2. I move a unit above and a unit below. Okay, you know what? That's a bit. There. Let's make it bigger because it's kind of congested. So I would move to r equal 2 like we said. There's r equal 2. I would move a unit above it and a unit below it. 1 above 2 is a 3, 1 below 2 is a 1. And a graph of a sine wave starts at the center. Instead of running up, it's going to run down because it's upside down. And one graph will do for almost all of these graphs. This is 2 pi. This is pi. This is pi over 4. Pi over 2, I'm sorry. Pi over 2. So that is 1 pi over 2, 2 pi over 2, 3 pi over 2, and 4 pi over 2. That'll work. Since it's all positive, I know it's this shape. And how does that work? Well, let's trace and start coloring. If I start with at 0 I am at 2. 0, 1, 2, here I am. Decreases, it's going to go inside. By the time I reach pi over 2, r equal a 1. There's pi over 2, and there's a 1. Then what? Then it increases. By the time I reach pi, I am at 2. There's pi, and there's 1, 2. So there it is. I knew it was going to look like that. I know the right half is identical to the left half. How about between pi and 3 pi over 2, r is positive. I'm in quadrant 3. By the time I reach 3 pi over 2, r equals 3. There's 3 pi over 2, and there's 1, 2, 3. And then what? Then decreases back. By the time you reach 2 pi, you are at 2. There's 2 pi, and there's 2. Of course, the graph is a smooth curve. And there it is. How about part G? If I go to G and I sketch a graph of one period, I have r equal 1. I go up 1 unit. And make sure you label that. 2 units above, that's r equal 3. And 2 units below, that's r equal a negative 1. A graph of a cosine wave starts on the amplitude, runs down to the amplitude, back up to the starting point, and we're done. And there it is. This is 2 pi. This is pi. This is pi over 2, and this is 3 pi over 2. So the main points are right there. Let me start the tracing. Now, I am aware that this is the graph of, let me put it right here. I know this is a graph wrapped around the cosine, the x-axis positive, and I know it has the loop. How do I know that? This is r equals 0. I have that labeled clearly. And since the graph runs below and above it, r is negative and positive, that's where the inner loop gets traced. So I need 3 of those circles. Let me eliminate one of those. There we go. That's 3 of them. Very good. And let me shrink this just a bit. And center that again. Perfect. Got it. Okay. Now, let's do the graph. If I look at 0, I am at 3. There is 0, there is 1, 2, 3. Decreases. By the time I reach pi over 2, r equal 1. There's pi over 2, there's 1. Now comes the tricky part. Decreases. It hits 0 before I reach pi. Between pi over 2 and pi. This is gonna decrease and hit 0 before I reach pi. Somewhere in there. I don't have to guess. I could figure out exactly where that is. Where does that equal 0? That's when cosine of theta equals negative 1/2. That's a reference angle of pi over 3. And where's cosine negative? In quadrant 2. What's pi over 3 in quadrant 2? 2 pi over 3. And it's negative in quadrant 3, 4 pi over 3. I know exactly where that's going to hit 0. That's going to hit 0 by the time I hit, and I'll fix that in a minute, and 4 pi over 3 is right there. So I need those points, and I label them clearly because this guy wants everything labeled. There, perfect. Everybody's happy. Now what? Now, I gotta make sure when I do the orange, I'm gonna hit 0 before I reach that. Now, between, I need a thin color now. Now, between 2 pi over 3 and pi, if r is positive, I'm right there. But do you see that r is negative? I'm right there. By the time I reach pi, r equal a negative 1. There's pi, and negative 1 is right there. Between this line, so it has to be to the right of that. That's how the loop gets generated. Again, starting at 2 pi over 3, I'm right there. Between 2 pi over 3 and pi, if r is positive, I'm right there. If r is negative, I'm right there. By the time I reach pi, I am at negative 1. There's pi and there's negative 1, connecting the smooth curve. Now, I know how this graph looks like. It's right there. I could just mimic the rest, but I'm not going to do that. I want to practice, and I'm going to do it working out point by point. Let's go by blue. So, between pi and 4 pi over 3. Between pi and 4 pi over 3. If r is positive, I'm in quadrant 3. If r is positive, I'm in quadrant, you start at pi, I'm in quadrant 1. So this increases, but it's still negative. By the time I reach 4 pi over 3, r equals 0. 4 pi over 3 is right there. So I am here already. I come back. Before I reach that angle, I zero out again. Now, between between 4 pi over 3 and 3 pi over 2. Right there. That small piece. R is positive. It increases. By the time I hit 3 pi over 2, R equal 1. 3 pi over 2, 1 is right there. Right past that angle. There it is. And then what? It'll keep on increasing. By the time I reach 2 pi, R equal a 3. There's 2 pi, there's 3. And that's how you generate the entire graph. And you need not to understand this, you need to master this. Let's do another one. I know one is never enough. Let's do another one. Let me shift this up a bit. And let me put it right there. Perfect. Okay. So let's start. We know what this is the graph of. We know it's either a heart shape wrapped around the negative y-axis. So it's either one of those or it's one of those. Well, let's start. R equal 2. I'm going to go up 1, 2. Amplitude is 4. I'm going to go up 1, 2, 3, 4. If I am at 2 and I go up 4, that's 6. And come down 1, 2, 3, 4. If I start at 2 and move down 4, I am at negative 2. A graph of a sine wave starts at the origin. Instead of running up, it's going to run down to the amplitude, back, up to the amplitude, back to the start. And that's one full cycle. So this is 2 pi. This is pi. This is pi over 2. And this is 3 pi over 2. I notice this switches sign from positive to negative. So it has to be this case. If that's the case, I need to know where the inner loop traces. Set this equal to 0 and solve it. Set this equal to 0. The sine of theta equals 1/2. I have a reference angle of pi over 6. Where's sine positive? So pi over 6, that's where it's going to hit 0, and 5 pi over 6. So I know exactly which angles to label on the graph. I need the pi over 6, the 30 degrees, and the 30 degrees. I need those graphs because this guy's really picky and he's going to insist on you labeling those. And if you don't, you lose most of the credit. And how does this work? Let's start in the beginning. At 0, I am at 2. There is 0, there is 1. Oh, it's 6. I don't have 6 units. 1, 2, 3. Okay, let's say this is 2, 4, 6. We're going to ignore the last. Let's take it out. There we go. 2, 4, 6. Double those. So at 0, I am at 2. I'm right here. Decreases. I notice by the time I hit pi over 6, I am at 0. This is 0. So this decreases. Let me just, for the sake of the graph, increase that just a bit. Just so that I could squeeze the line in nicer. So even though that's not the case, that's okay. We're going to cheat just a bit. We're going to say not wrong scale. So this is going to decrease and hit 0 before I reach that. By the time I reach that point, I am at 0. Now what? Now comes the really part you got to pay attention to. Between pi over 6 and pi over 2. Between pi over 6 and pi over 2. If r is positive, I'm right there. If r is negative, I'm right there. Meaning, if I told you pi over 4, negative 3, wouldn't you rotate to pi over 4 and you move 1, 2, 3 back because it's negative? Aren't you in this quadrant? So that's what you need to get out of the way. So, this now is negative between pi over 6 and pi over 2. So I'm right here. By the time I reach pi over 2, r is negative 2. There's pi over 2 and there's negative 2. Where? From that angle right there. Got it. I'm developing this loop. Then what? Obviously it's going to come back. We know that. So this increases back. It's still negative between pi over 2 and 5 pi over 6. If r is positive, I'm in quadrant 2. But if r is negative, I'm right there. So it's going to pick up. Before you reach that line, it's going to zero out again. Now that small tiny piece, that piece right there between 5 pi over 6 and pi, 5 pi over 6 and pi, r is positive. I'm in quadrant 2. It's right there. It's picking up. And by the time I reach pi, r equal to pi 2. It picks up there. And then what? Then it keeps on increasing. By the time I reach 3 pi over 2, r will equal a 6. 3 pi over 2, 2, 4, 6. So it keeps on increasing. And obviously, you know what's going to happen. It's going to come back. Decreases. By the time I reach 2 pi, I am at 2. There's 2 pi, there's 2. And it comes back and closes. And it starts retracing its steps. So it starts doing the same thing again. Okay, I'm going to stop this video here and wrap up with the last video.